All right, and here is our last unit that this semester covered. It was our chemical reactions unit. We're first starting with what is the law of conservation of mass? This is where mass can not be created nor destroyed. It just changes forms, right? It just changes chemical composition. Just changes chemical composition or makeup. All right. So when we have these, this idea, it's anytime we have a chemical reaction occur, there is a chemical change occurring, which means that there is a change into the identity of these substances. However, we still need the same amount of everything on both sides, same amount of every atom on both sides, because that mass doesn't go away, and also it just doesn't come from nowhere. So for number 34, we're going to identify all those check boxes there. We give you that aluminum is more reactive than hydrogen in this case because it is a single replacement reaction, and aluminum was not one of the elements that we tested in lab to create our activity series. So aluminum metal. So write the full chemical equation, including states of matter. Aluminum metal is Al with a solid designation. Is added to sulfuric acid. All acids are going to be aqueous solutions. To produce hydrogen gas, remember hydrogen is Hänkel-Brief or Brinkelhoff or Hobberfinkel or whatever you want to remember it by, but because it's by itself right now, it is existing as a diatomic, as a pair. Hydrogen gas plus a solution of aluminum sulfate. Now, because we are creating a new ionic compound, we need to make sure that we balance the charges. This is aluminum sulfate, so this is AlSO4. SO4 is a -2 ion charge. Aluminum's a +3, so I actually need 2 aluminum, and I need 3 here. All right. And so that was a solution, which means aqueous. So I have everything here. I wrote in the full chemical formula. I just need to balance the equation, and we kind of already did identify. Again, this is a single replacement because I'm starting with one element and one compound. And I'm creating a new element, a new compound based on one replacing the other. And only one replacement because only one thing changed partners. The other one now does not have one. So the last thing to do is balance. And so I look at this and I identify a couple of things where I now have 2 aluminum on the product side, so I need a 2 in front of this aluminum. I do also have 3 sulfate groups on the right side, and there's only one sulfate group here. This 4 might lead you to believe there's 4, but again, remember that 4 is part of the sulfate ion identity, and so we can actually treat this like it's one package and be able to better balance this, or more easily balance this, I should say. So I don't usually put those parentheses around, but you can if you notice that there's a package on both sides, a polyatomic ion on both sides. And putting a 3 here gives me 6 hydrogens, so I need, of course, 3 in front of this hydrogen too. If I don't put anything, then it is just 1. You would not be penalized for putting 1 if you want, but again, something that I don't usually do just due to how it's technically not supposed to be written there. It's what we call understood as a 1. Kind of like there's 1 sulfur here or 1 aluminum there, and we just don't write the 1 as a subscript either. When potassium reacts with bromine, potassium bromide is formed. Write the full chemical equation and balance. In this case, I don't expect you to just know off the top of your head what states of matter are, but you should know that potassium is by itself and bromine is by itself. And because bromine is by itself, it should be Br2 because it's part of Hänkel-Brief. It's a diatomic, and potassium bromide is formed because one's a metal, one's a nonmetal. we need to make sure we balance the charges appropriately. In this case, we only need one potassium with one bromine ion, and that means that we need 2 in front of both the potassium and the bromine there to make sure everything is balanced, all conservation of mass. Classify this reaction as synthesis, decomposition, single replacement, double replacement. Explain your reasoning. Because we're starting with 2 elements, all right, so you could say we start with 2 elements alone and form 1 compound. This is a synthesis reaction. All right, and our synthesis reactions, again, are anytime we have 2 elements at the beginning and our reactant side, and those are going to come together. More often than not, they are going to be ionic compounds, right? Positive and a negative. Identify the type of reaction in following for the following in balance. Here I see that I'm starting with 1 compound plus another compound. This is going to make way for 2 replacements. So this is what is going to be considered a double replacement, which is what causes it to be different than the single replacement because there are 2 new partnerships forming, not just 1. And then we balance. I'm sorry I didn't give you this is in a very odd spot, but something that I like to look at first is things like the metals and see how we're looking there. And the first metal that I notice is calcium, where I only have 1 here and then I have 3 here. You could have done that with the sodium too, and you'll start to see some other patterns as to which one might be more beneficial to start with. Again, there's no one right way to balance, but because I noticed this, I'm going to put 3 as a coefficient in front of the calcium chloride there. That's going to change my number of chlorine as well to 6, right? 3 times 2. We are multiplying when we put coefficients out. So I need 6 chlorine on this side, which means I need a 6 there because there's only 1. That's going to provide me with 6 sodium atoms on that product side, which means I need 6 sodium atoms on the left reactant side, which also means that I need a 2 in front. 2 times 3 gives me 6. And then what I notice is that by putting this 2 here, this also gives me 2 of these PO4 groups, which I also have that many on the product side. So everything is now balanced out appropriately. Ammonium nitrate, it breaks down to produce nitrogen gas, oxygen gas, and water. This is a very rare time where I will give you a something that produces more than 2 substances, but it's nice to have one of these once in a while. So breaks down, that tells me that this is a decomposition. And let's write that a little bit neater. Sorry. Decomposition. Because it's breaking down, because we're starting with 1 thing. So this is ammonium nitrate, NH4NO3, breaks down, produce nitrogen gas. Now remember, nitrogen is Hankelbrief, so that is N2. Oxygen gas, which is O2, and water, which is H2O. And so this looks like kind of a crazy one to try to balance here. So there's going to be, and it's okay to have this, there's going to be some points at which you're going to have to, it's not guess and check, but you might have to make an adjustment to one thing that then changes how much of another thing there is. Looking through this, I mean, you could see that we have the right amount of nitrogen on both sides. We have the right amount of oxygen because there's 2 here plus this one. That gives us 4 total. And then what we also see is that the only thing that's really kind of messed up here is our hydrogen, right? And so what we could do is take a look at those hydrogen first. Why not? And we see that because I have 4 here, I definitely need 4 on the product side. So I would get 4 by putting a 2 in front of the water there, because it'd be 2 times 2, which would get me 4 hydrogen. And that also gives me 4 oxygen on that right side, that product side, which I don't have 4 oxygen on the left side. Now, the only thing that the smallest number that I could change on this side would be by putting a 2 out in front here, which would give me that would give me 6 oxygen here. And so now that we've changed oxygen, what's nice is that by keeping this here as a 2, we'll then now need to change it to change our number of hydrogen on the product side. And why I say that's nice is because now we're going to be able to have an updated version of oxygen there as well. So by making this change, we will end up needing 4 in front of that water, because we need 8 hydrogen now because we have the 8 hydrogen here. And then by doing this, we get 4 oxygen plus the 2 here, so that gives us 6, which we have over here as well. So actually, by changing this to be an even number of oxygen on this side with the 2, that helps us out over here. Again, that's why I kind of said it will end up working pretty nicely. But then we cannot forget that we have now 2 nitrogen there, plus the 2 more nitrogen here. 2 times 2 is going to end up being 4, so we need 4 nitrogen here. And of course, we don't need anything in front of the oxygen there. So kind of a weird one to balance, but yeah, I wouldn't worry too much about these types. It's nice to have more than 1 or more than 2 products sometimes, just to kind of get the thinking going a little bit more. But last but not least, based on the activity series, which of these following reactions will not occur? Remember, the activity series is the one that we use based on the lab that we did to discover these the reactivities of these metals here. And we identified that the most reactive was magnesium, and the least reactive was silver. And so this is the ability to identify, hey, if the element that's all alone is more reactive, then this will happen. If not, then this won't happen. So I just want you to say yes or no, and then because it's a yes, then I will then go through and proceed with the reaction as well, just so you can see that. Magnesium is more reactive than hydrogen. So this does happen, so I say yes. And so what's happening is the magnesium kicks hydrogen out, so hydrogen is now by itself, which means it has to be H2. Magnesium is now with the chlorine, but because magnesium has a positive 2 ion charge and chlorine has a negative 1, I need 2 chlorine there because I will crisscross those. And then I'm going to put a 2 out in front of the HCl there to balance this. Zinc is more reactive than lead. We can see that. Therefore, this does happen. Lead ends up by itself. Zinc is a positive 2 ion charge always. Nitrate's a -1. I do need 2 nitrate groups again because zinc has the same charge as the lead that it was with already, which means that this is already balanced. So that happened, and we showed how it happened. Copper is more reactive than silver, therefore this does happen as well. Silver is now by itself. Copper is with the nitrate group, and I know that this is going to be a +2 with a -1. You will be given the charges of the transition metals for something like this, but then that also will need me to put 2s in front of the silver nitrate and the silver there. So that happened, but this one is a no, because copper is not more reactive than hydrogen, which means that it cannot replace this. So then we would just say no reaction here. All right, and these are all single replacement reactions. So hopefully these videos helped, at least point you in the right direction. And if you have questions, of course, as always, please reach out to me. See you later.